In acidic medium, oxime can rearrange to give amide. This rearrangement is called Beckmann rearrangement. For example, we have this oxime. It will rearrange to give this amide. We can also have cyclic oxime. In acidic medium, it will rearrange to give cyclic amide. Cyclic amides are also called lactam. So let us write product for this reaction. So this is a oxime. So final product will be amide. And this reaction is Beckmann rearrangement. Now let us derive product using mechanism. In the first step, we will have protonation. So OH group becomes a good leaving group. So in the next step, we will have loss of leaving group, and the same time we will have alkyl migration. So loss of leaving group and migration of alkyl group occurs at same time. Now in Beckmann rearrangement, we always have anti-migration. That is, leaving group and migrating group are anti to each other. Anti-migration means leaving group and migrating group are anti to each other. So in this case, we are migrating this bond. That is, we are connecting nitrogen to this carbon. This bond is broken and connected to nitrogen. So we will have a 7-membered ring containing nitrogen. Nitrogen and carbon number 2 is connected by a double bond. Carbon number 2 will also have a positive charge. So this is the intermediate we will have. Now the next step, will react with one molecule of water. So water is acting as a nucleophile. In the next step, we will have deprotonation. So water will act as a base and it will deprotonate. And finally we will have this product. This product will tautomerize to give amide. This is a cyclic amide. This product is called Carpolactum. So common name for this amide is Carpolactum. And Carpolactum is used as a monomer of nylon 6. So this is a monomer of nylon 6. So if carpolactam gets polymerized, it forms nylon 6. So this is Beckmann rearrangement in cyclic system.